Welcome back to the College of Glycation, where we uncover the role of glycation, which is a biochemical breakdown that silently sabotages our health. I'm your host once again, Paul Reynolds. I'm a biomedical scientist and professor of cell biology. And today we're discussing a topic that's key for anyone who hits the gym, runs the trails, or just wants to stay active as they age. The title of our glycation topic today is Glycation and Exercise: How Muscle Damage and Recovery Can Be a Challenge. So, if you've been following our series, you know we've uncovered the fundamentals of glycation in past episodes. But let's quickly refresh for those tuning in for the first time or needing a reminder. Glycation is essentially what happens when sugar molecules in your bloodstream, think about in this case glucose from carbs or fructose from sweets, stick to your proteins or fats in your body without any enzymatic regulation. It's like a haphazard chemical reaction that forms these sticky, dysfunctional compounds called advanced glycation end products, or AGEs for short. These ages accumulate over time, especially if your blood sugar runs high frequently, and they wreak havoc by cross linking with important structures, making them stiff, brittle, and oftentimes less functional. But it's not just a diabetes thing, mind you. It happens to all of us, but faster in those of us with poor diet or metabolic issues. Now, in this episode, we're zeroing in on how this process sabotages our muscles during and after exercise, how it therefore ramps up injury risk, particularly if you're older or dealing with blood sugar problems. And we'll also talk about what you can do about it. We'll back it all up with solid science because understanding the why can motivate the how. So let's get into it. First off, let's talk about the basics of how exercise interacts with your muscles on a cellular level and where glycation can throw a wrench into the works. When you work out, whether it's lifting weights, doing yoga, or sprinting, you're essentially causing controlled damage of your muscle fibers. Tiny tears form, inflammation kicks in as a signal, and then your body repairs and rebuilds those fibers stronger and more resilient. That's the magic of adaptation. It's why you can fitter, why you get fitter over time. But glycation interferes with this repair process right from the start. Ages can build up in muscle tissue, cross linking with the collagen that you find there and other proteins that give muscles their structure, contractility, and elasticity. Imagine your muscle fibers as a network of rubber bands. Glycation makes them more like a dried out, cracked rubber band that snaps easily and doesn't bounce back. Studies show that in people with higher age levels, muscle repair is slower because ages trigger chronic inflammation and oxidative stress, which both work to overload the cells that are trying to fix the damage. This isn't just a theory, mind you, it's evident in folks with diabetes or prediabetes, where elevated blood sugar accelerates age formation, leading in the process to poorer recovery after workouts. Even in non diabetics, if you're pounding sugary energy drinks or high carb meals regularly, you are fueling this process. So let's drill down into how glycation specifically impairs muscle function. One big issue is reduced flexibility, or what we might call findability in a lay sense. In reality, it's really about the tissue's ability to stretch and contract without tearing. Ages cross link collagen in the extracellular matrix of your muscles and the supportive scaffolding that make your muscle cells sound, making it in the process more rigid. This stiffness means your muscles cannot absorb shock as well during exercise, increasing the odds of strains and tears. For aging populations, this is amplified because age accumulation naturally speeds up with time. You can think of it as biological rust, which we've talked about before, building up in your engine. In diabetic individuals, it's even worse because high blood sugar creates a perfect storm for even more ages, which then contribute to sarcopenia, that age-related loss of muscle mass and strength. Research highlights how ages activate pathways that promote muscle atrophy, leading to problems. It essentially tells your cells to break down protein faster than they're able to build it up. This leads to weaker muscles overall, slower recovery times, and higher injury risk during activities that should be building you up, not breaking you down. Active people aren't immune. Keep in mind, if you're an endurance athlete or weightlifter with a diet that's unknowingly high in sugar, you're setting yourself up for cumulative damage that shows up as nagging injuries or plateaus in your performance. Speaking of diets, let's address how high sugar intake directly sabotages your workout recovery. You might think of post-gym smoothie with fruit and honey as harmless fuel, but if it's spiking your blood sugar repeatedly, it will not be as productive. High sugar diets lead to hyperglycemia, where excess glucose floats around and, in this case, glycates proteins in your muscles and bloodstream. This process will, in fact, impair your insulin signaling, which is your body's way of shuttling nutrients into cells for repair. And it promotes, in this case, what's called insulin resistance in your muscles. That's where your muscles do not respond to the signal that insulin provides effectively. The result is your muscles don't replenish glycogen stores efficiently. Your inflammation post-workout lingers longer, and protein synthesis, the key to rebuilding stronger fibers, slows down to a halt. Science shows that even short-term high sugar consumption can blunt the adaptive response to exercise, meaning you don't get the full benefits from your sweat sessions. For example, in active individuals, elevated blood sugar prevents the shift in muscle fiber metabolism needed for endurance or strength gains, in this case, leading to fatigue, soreness that drags on, and slower overall progress. It's like revving your engine with contaminated fuel. You might move, but you're wearing out the parts faster. It's especially problematic in aging or people with diabetes, where baseline glycation is already somewhat high, turning what should be a recovery boost into a setback. But glycation doesn't stop at muscles. It worsens tissue health throughout the body, as you know, creating a ripple effect that hits active individuals hard over time. Take your arteries, for instance. They are the highways that deliver oxygen and nutrients to working muscles. Ages accumulate in vascular walls, cross-linking with elastin and collagen, which stiffens them and reduces their ability to dilate. That, of course, is a problem during exercise. This arterial rigidity means less efficient blood flow during exercise, and that will lead to your quicker fatigue. It also leads to higher blood pressure under load and increased cardiovascular strain. In active people, this can manifest as reduced performance in high-intensity activities or even contribute to conditions like atherosclerosis down the line. Studies, in fact, link higher age levels to greater inflammation in blood vessels, promoting plaque buildup and oxidative damage that echoes what we see in diabetes or accelerated aging. For someone who's fit but indulges in a high sugar lifestyle, maybe carb loading gone overload, it's a hidden tax on your longevity. Your heart and muscles work harder just to maintain output, increasing injury risk indirectly through poor perfusion and nutrient delivery. It's a systemic issue, right? Glycation is one area that can spread to others. Glycation, for instance, in one area feeds problems in another, turning exercise from a health promoter into a potential stressor if you don't manage it well. So, enough of this negativity. Let's shift to some solutions because knowledge without action is really just trivia. The good news is there are evidence-based ways to combat glycation and optimize your muscle recovery. First, you can consider anti-glycation supplements. A good one is carnosine. Carnosine is a dipeptide made from beta-alanine and histidine. It's found naturally in meat, but often supplemented for its potent effects. It acts as a buffer against age formation because it scavenges reactive sugars and reducing oxidative stress in muscles. Research shows that carnosine can improve muscle function, speed up recovery after intense exercise, and even protect against glycation-induced atrophy. For active folks, especially those over 40 years of age or with metabolic concerns, some data show that dosing with around 500 milligrams daily may help maintain flexibility and repair efficiently. Pair that with optimal post-workout nutrition. Skip the sugary recovery shakes and instead go for protein-rich meals with low glycemic carbs like eggs, some vegetables, and nuts. This keeps blood sugar levels stable, minimizing new age formation while providing amino acids for essential repair. Now, timing matters. If you eat within an hour post-exercise, you could maximize nutrient uptake without the spike. On the training side, let's consider tweaking your routines to minimize damage while building resistance or resilience. Incorporate more low-impact sessions like swimming or cycling to give glycated tissues a break from high-stress pounding. Focus on progressive overload with recovery in mind. Shorter, more frequent workouts rather than marathon sessions that exacerbate inflammation. Strength training with eccentric emphasis can slow lowering phases, and that can basically allow you to build better tolerance. But pair it with mobility work to counteract any stiffness. For diabetics or older athletes, monitoring blood sugar before and after exercise is key. Aim to keep it steady to avoid fueling glycation. Lifestyle tweaks can, in fact, amplify this. Let's consider cutting processed sugars, emphasizing more the whole foods, and consider intermittent fasting to lower overall glucose exposure. The science backs this holistic approach. Reducing age intake and formation not only aids muscle recovery, but enhances overall vascular health, letting you stay active longer without the breakdowns. As we wrap up this episode, remember glycation is an adversary, but armed with this information, you can outsmart it. Exercise is still one of the best tools we have for health, but pairing it with smart anti-glycation strategies turns it into a superpower. Thanks everybody for joining me at this College of Glycation session. Please remember to stay curious and stay moving. Exercise is key. I'll catch you next time.